people talk about blue carbon. They talk about how much eelgrass and salt marshes store carbon underneath in the plants and in the sediments below. And what we're interested in learning about is how much carbon is actually permanently sequestered, permanently stored in the sediments below the eelgrass. So in order to do that, we have a project that's been going on for the last little while, where we've mapped out different areas where we have eelgrass beds that are vegetated, and then we have other beds that are barren, they're void of eelgrass. And we're measuring the amount of carbon that's in those sediments in those two areas. The way we do that is we collect sediment cores. We get a long cylinder, it's about 75 centimeters long, and it's about 4 inches in diameter, or about 10 centimeters. And then we pound that into the ground, then we have to dig it out, and then we collect that core, and then we section it into pieces, and we send it off for analyses. From that, we can then learn how old the sediments are, how much carbon is actually in those sediments, and also if we're able to do what's called stable isotopes, we can actually identify the source of the carbon. Did it come from the eelgrass, or did it come from terrestrial plants, or did it come from seaweeds? So with all that information, we're then going to try to find out if there really is a difference in the amount of carbon that's sequestered underneath eelgrass beds versus barren sites. Then after that, what we're also doing is we're now going to plant one portion of the barren sites, and then we will be able to set up a long-term monitoring project so that we'll have a vegetated area, a barren area, and then a newly planted area, and to see if we can monitor change over time in the amount of carbon that's actually sequestered in the sediments.
So we're going to be collecting today, outside of the study plots, eelgrass, and we need to have a certain density. So for 250 square meters that we plant tomorrow, we need 10 plants per square meter. So we're going to be trying to collect 2,500 eelgrass plants today during the low tide, and then once we've got them, we'll start tying washers on for the weights for the planting tomorrow.
So eelgrass we know is important in the estuary. Comox estuary has a lot of eelgrass, both intertidal and subtidal. And eelgrass can provide a habitat, a refuge for salmon fry as they're exiting the river, so that then they don't get preyed upon. It may also provide a habitat for the types of organisms that small fish and larger fish may eat. We also know that eelgrass can act as a dampener for any kind of wave action that might occur. So if there's any significant storm surges in an area, areas where there's eelgrass, it actually has a bit of a dampening effect as the wave comes in. And then thirdly, we also know a little bit about that eelgrass may act as a source of storing carbon in the sediments.